Welcome to Brain Vision.
For this question, you choose the following reference frame. My vertical axis, which I will call the y-axis, will point upwards. And this is all we have to do with respect to the reference frame. Now, the situation is the following. There is a man that's trying to pull himself up this tree through this nylon cable. And to do that, he pushes one end of the nylon cable, and by doing that, he produces a tension. And this tension should be bigger than his weight so that he can pull himself up. To calculate his acceleration, we should write Newton's second law, as this is the only equation we ever know that relates forces with accelerations. Then, applying Newton's second law to the y direction, we get that the net force in that direction is equal to the mass of the man times his acceleration. The net force that is being exerted on the man is composed by three forces: his weight force, the tension force that acts on his waist, and the tension force that acts near his hands. Then, Newton's second law tells us that 2 times the tension force minus the weight force is equal to the mass of the man times his acceleration. Then his acceleration is equal to 2 times the tension force minus the weight force divided by his mass. One question that might arise now is why haven't I considered the force F on this equation? And the reason is the following. I'm applying Newton's second law on the man. Therefore, we should consider only forces that are being exerted on the man. This force F is being exerted by the man on the rope, so we shouldn't consider it when dealing with the man itself. Then, now all we have to do is calculate what is the value of the tension force. But this is not difficult to do. Newton's third law predicts that this force F that the man exerts on the rope is equals to the force that the rope exerts on the man. So one of the tension T is equals to the force F, and the other tension is also equal to the force F. Therefore, the tension is equal to the applied force. So effectively, this log is multiplying the applied force by 2. Then, his acceleration is given by 2 times the applied force minus the weight force, which is his mass times the gravity acceleration divided by his mass. Then, plugging in the values that were given by the problem, we get 2 times 358 minus 72 times 9.8. Remember, g is approximately 9.8 meters per second squared near the surface of the Earth, and this is divided by his mass, 72. This results in an acceleration of approximately 0.14 meters per second squared.